Hey 20-1s, welcome to a quick video on geometric series. So you've done series before at this point, but with arithmetic sequences and series. So now what we're going to do is essentially do the exact same idea, just now we're doing it with geometric sequences. So remember, all a series is us finding the sum of a geometric sequence. Okay, same as before with arithmetic. Now, I'm, again, not going to prove these formulae to you. They're on your formula sheet. They're always given to you. And same as arithmetic, you're going to be given two different options. And so when we derive them, they derive from kind of two different places. But the same as in arithmetic, I guess the question is when are we going to use which one? Okay, and we'll talk about that in just a second. And remember, we know what Sn means. It means the sum of the n terms. T1, well, that's my first term. And again, just in case I've said it in the other videos, if you see anyone ever say A instead of T1, that just means your first term. R we know is our ratio, and n is the number of terms. Okay, so I've got two formulae here. Which one am I going to use when? Well, look at the difference between the two again. If I look at the second one here, if you notice on the second one, I know that last term. So I'm probably going to use this one when I know the value of the last term. And on the first formula, look at, I don't know the last term or the value of the last term. So this is when I'm going to use this one, when I don't know last term. Then the same thing that happened in arithmetic series, if you recall, is on occasion, though, what you need here is you need the n. And so sometimes we might have to find out how many terms there are, but we'll see as we go through the questions just how to play around with these things. So there they are. Don't need to memorize them. I don't have them memorized. Like when I'm not teaching 20-1, I'll promise you I don't have them memorized either. That's why we have a formula sheet. Okay, let's do a few examples. So first one says, given the series, determine the sum of the first 7 terms. So again, first thing I want to recognize is that this is a geometric series. I'm multiplying each time by -2. So there's the first thing I want to recognize. Okay, so what do I know? Let's write down what we know. Well, we know term 1 is -3. We know the ratio is -2. We want the sum of the first 7, right? Just like that. And then that would mean that n is 7. So then I say to myself, well, which formula am I going to use? So I'll scroll back up here. Well, I don't know the value of the last term, so I'm going to use the first formula. Again, make your math teacher happy. Always write down your formula or your general term that you're going to use. Always do that, pretty please. And then now we just sub in our values. And that's what I like about this unit is once we've kind of figured out which formula we're going to use, you just sub in your numbers, right? Okay, so I sub everything in, but I want to make a note here about something, a small mistake that comes up. I'm going to do this. I made 2 mistakes. I didn't do that one on purpose. N is 7. Okay, so I'm just going to make that a 7. Okay, what I would prefer you to do, though, is remember, if you're using your calculator, you want to put parentheses around that -2. Okay, that will help eliminate a few small mistakes, especially if that exponent was an even number. So I always put that in. I almost kind of wish it was displayed that way, but it's not. And then again, friends, just don't sub everything in your calculator. Try and do a little bit of simplification first. 2 to the 7, what's that? 128. So -128 minus 1, -3. Oh, that was convenient right there. Do you see the -3's divide out? So the sum of your first 3 terms is -129. So we can have a sum that's a negative. All that means, again, is that there's more negative terms in our sequence than there were positive terms. That's it. Okay. So again, when we're looking at these things, just be careful that if the ratio is negative, if we're switching, we're alternating signs like that, that your ratio over here includes that negative. There it is. Okay, let's take a look at another one. Determine the sum of the series. Bang. Okay, so fractions, as soon as I give fractions, that makes things a little bit more difficult, but not too bad. So I say to myself, it's geometric. Which formula am I going to use? Well, here I know the value of the last term. Okay, so what I'm going to do is I'm going to use this formula. Because in this formula, what do I need to know? The ratio, the last term, and the first term. And I know those things, or I can figure those out. Term 1, 1 over 64. Tn, well, that's 1,024. But what about r? Well, remember, to find r, your ratio, all you do is you take any term you want and divide it by the previous term. So I'm going to go 1/4 divided by 1/16. And multiply by the reciprocal. Well, guess what? The ratio ends up being 4. There we go. Now watch. Sub that into the formula. So the sum of this series, so Sn, r we just said was 4, Tn is 1,024 minus term 1 over r minus 1. And again, let's just simplify down a little bit before we just start subbing all of this into our calculator. 4 times 1,024, what's that? 4,096, I believe. Hey, not bad. Minus 1 over 64 over 3. And so here, I mean, I could get a common denominator in the numerator, but let's just use our calculator at this point. So I put the numerator in my calculator and then divide by 3. And I always want my answer as a fraction if I can, but this one's going to end up being a decimal for us. What are we going to get here? 1,365.3. Okay, so there's your sum of that series. Not so bad. If we had tried to use the other formula, we would have to go and find n. So it would make that question a lot more work. So this was kind of the easy way to attack that question. Okay, let's try one more. So here's an application question. A ball is dropped from a height of 15 meters and bounces to 60% of its previous height. How far has the ball traveled vertically, that's an important word, when it hits the ground for the 4th time, round to the nearest 10th? Okay, so first thing we should do is maybe let's visualize what this is looking like. So we're dropping the ball that bounces. It's dropped from a height of 15 meters. And bounce 1, I'll just call it B1, B2, B3, and B4 when it hits the ground for the 4th time. So that would be that one right there. Now we want the vertical part. So the vertical part of this is this straight up and down right here, just like that. Okay, so we want that vertical height, and let's not forget that right there. Okay, so there's our visualization of how we're going to attack this question. Now, it's geometric because it's returning to 60% of its height each time. So we're really taking the previous height and multiplying by 60. So if I wanted to make a geometric sequence out of this, the initial term would be 15, and there's my ratio, n minus 1. Okay, but we want how far it's traveled. So we don't want the sequence. We want the series for this thing. So which formula am I going to use? Well, I don't know the value of the last term. So I'm going to use this formula. Right? No, I don't want to use that formula because I don't know the value of the last term. I want this formula. And we're going to use this one. T1 r to the n minus 1 over r minus 1. Okay, so not this one. That was a lie. All right, so let's figure out what we want here. So let's sub this in. So how many bounces do we have here? Well, we've got 4 bounces. So we want the sum of the first 4 bounces. T1, that's 15. The ratio is 0.6. 4 minus 1. 4 minus 1. Okay, definitely pick up a calculator for that one. And take a quick second. 4 minus 1 divided by 3. Oops, I think I'm getting a wrong value there. So put that in your calculator and you get, oh, there, small mistake right there. Sorry, friends. R is 0.6. Put that in your calculator and you get 32.64. Okay, but that's not actually the sum of the vertical distances, because I'm just going to switch pen colors here. What did we just find? Well, we found this distance here going down each time. But we've got to remember the ball is going to go up to that distance and down that distance as well. So what are we going to do here to our answer? Well, the easy thing to say is if this is us, this is the going down part, and I want that up part, I'm going to multiply by 2 to get that up part. Okay, so I multiply that by 2. And that would be the down and the up that I've traveled, or the ball has traveled. But we've just got to be a little careful here, because on the very first one, that ball didn't go down and up, it just went down. So now what I'm going to do is I'm just going to subtract one of those initial heights out. So we were initially at 15 meters, and so subtract that out, and we're going to be at 50.28, and it said to the nearest tenth, so I'm going to say 50.3 meters, I believe it was. So when you get this kind of the ball bounce question, which is a very standard question for series, I don't know why, what you again want to think about is you find the sum of your terms. So find the sum of how many bounces. Then you're going to multiply that by 2 to get the up and down portion, but then you're going to subtract the initial height because it doesn't go up and down. It only goes down. Okay, so the ball bouncing question, unfortunately, a pretty standard question. Now, there is another way to do that question, my friends, but to me, I like this way. I think it's the easiest way to do it. Okay, you are done geometric series.